in this problem we are going to determine I naught and V naught for all time in the circuit shown below. So assume the switch S is closed for a long time. So if the S is closed for the long time, we have to consider the inductance as, if you have inductance, you have to short circuit, okay, and you have to find the current. Okay, if I have a capacitance, you have to open circuit and you need to find the voltage across the capacitance. So they have given that the switch is closed for a longer period of time, and so this is your I naught, and this is my IL of 0 minus, and this is your 2 ohm, and here only we need to find the voltage. Okay, so now this is your circuit. So you can see the 24 volt is divided across these two resistor, and I need to find the value of IL of 0. IL of 0 is flowing through the 2 ohm resistance. So to find the IL of 0 minus, since there is t less than 0, I'm mentioning it as 0 minus. Okay, so applying the current divider rule, so 24 into opposite resistance divided by total resistance is 6. So answer is 16 amps. Okay, so what is I of t? Okay, so what is I? I is equal to, here IL of 0, okay, 0 minus. So the I is nothing but 16 when t is less than 0. This is what it means. Okay, so if IL is 16 means, if this is 16 means I0 is nothing but 8, because 24 is put as 16 and 8. Okay, so I can write I0 is equal to 8 when t less than 0. So what is the value of V naught? V naught is equal to so 16 into 2 is 32. Okay, so we get 32 when t less than 0. So what is the next condition? The next condition is switch has to be open. Okay, so if switch has to be open means this 24 amps is not connected to the circuit. So that is the case. So the circuit will look like this. Okay, so what are the values? There is 3, 1, and this is your V naught, and value is 2, and this is 4 ohms. So the current flowing through this one is I naught, and this is I. Okay, so you can see here the IL of 0 is equal to IL of 0 plus. Why? Because the inductors will not allow the change in the instantaneous current. So IL of 0 plus is equal to IL of 0. Okay, and you can see here there is no source is present. Okay, if there is no source means the energy stored in the inductors get discharged. Okay, so I can write, so for energy discharging, I is equal to I of 0. Okay, I of 0, okay, that is here, that is IL of 0. Okay, IL of 0 into e power minus t divided by L by R. Okay, so this I can write it as IL of 0 into e power minus RT divided by L. Okay, so this is equal to this I can write it as IL of 0 e power minus t divided by tau, where tau is equal to L by R. Okay, so here the L, so I am going to find the current at this point. So at this point you can see these two resistors are in series. So if these two resistors are in series, and Okay, so I can write, I can redraw 3. Okay, so here only I need to find the value of r, and you can see this this resistance, so that is 4 plus 2, I can write it as 6. So here only I need to find the value of R equivalent. Okay, so so R equivalent is nothing but 6 in parallel with 3. Okay, so 18 divided by 9, that is nothing but 2. So here the R represent, it is R equivalent. Okay, so if I have only one R, that is that means it is R. Okay, so IL of 0 into e power minus 2t divided by 1. Okay, so what is IL of 0? IL of 0 is nothing but IL of 0 is nothing but 60. Okay, so it is equal to 16 e power minus 2t. Okay, that is nothing but I. Okay, so how this equation came means, we know that I is equal to I of infinity plus I of 0 minus minus I of infinity into e power minus t divided by tau. Okay, so here I of infinity is 0 because there is no source and I can't able to find the value of I of infinity, therefore it is 0. So I can find I is equal to, substitute 0 plus I of 0 minus 0 into e power minus t of tau. I can write it as I of 0 into e power minus t divided by tau. So this is how the equation came. So what is I? I is equal to 16 power e power minus 2t. Okay, so 16 e power minus 2t at t is greater than 0. Okay, so once if I find the value of I is something but 16 e power minus 2t. So I can find the voltage at this point, right? So this is 16 e power minus 2t. So voltage across this point is, what is the voltage across the inductance? It is VL. VL is nothing but L di of dt. Okay, L is 1. So differentiation of 16 e power minus 2t divided by t. That is nothing but minus 32 e power minus 2t. Okay, so this is your VL. So if I find the voltage across VL, I can find the IX current. Okay, so what is IX current? IX is equal to VL divided by 3. So what is VL? VL is equal to minus 32 divided by 3 e power minus 2t. Okay, so from this I can find the value of I naught. Okay, so what is I naught? Here you can see I naught plus I plus Ix is equal to 0. Okay, so what is I naught? I naught is equal to minus of I plus Ix. Okay, so I naught is equal to minus of minus 2t plus 16 e power minus 2t. Okay, so this is nothing but 48 16 by 3 e power minus 2t. So what is minus 16 by 3 e power minus 2t at t greater than 0. So I have found out I naught. So okay, this is nothing but minus I naught, right? Okay, So this is minus I naught means what is the voltage at V naught? V naught is equal to minus I naught into 2. So we know that I naught is nothing but 16 by 3 e power minus 2t into 2. So it is nothing but 32 by 3 e power minus 2t. Okay. So from this I can write this is 32 by 3 e power minus 2t at t greater than 0.